Okay, so we'll go with the second portion of our rhombus lesson. I'm going to do part of the proof for you. So I'm probably just to write statements and talk through it a little bit. And please feel free to write the reasons. I'm not going to do all the proofs that are on the homework. I'm just going to do a couple. So here goes with this one. They're going to tell us to start with that this figure right here is a parallelogram. Okay, to start with. Now, it might be more upgraded, but it is at least a parallelogram. Okay, now, JM is congruent to LM. All right, so we mark that. Angle, LMN, that's this one, is the same as LNM. So, a couple concepts here. That makes this triangle right here, get rid of that for a second. Okay, that makes this triangle an isosceles triangle. So using base angles theorem, we then get LM the same as LN. Now, with a parallelogram, if you get consecutive or adjacent sides congruent, it upgrades from a parallelogram to a rhombus. So that's our plan. So here's how we'll start. First statement, I'm going to begin with LMN congruent to LNM. Well, from now on, I'm not going to fill in the reasons. You guys can do that. All right. So next thing we're going to speak of, so number 2, we're going to say that LM is now congruent to LN. I said I wasn't going to do this, but I am going to do one more. It is by base angles theorem. Now, some folks might argue that it's the converse of the base angles theorem. They're correct. Others might want you to write it out further. I don't require it, but I will write it out so that if your teacher does require it, you can do this. So, angles, the base angles being congruent. So the base angles in statement 1 are congruent. So the sides across from them. So the sides opposite them in the triangle must be congruent. Okay, so if your teacher requires you to write out what base angles theorem is, they might want you to say it's isosceles. I don't know. I'm not as picky about that. Base angles theorem to me covers it, especially if you got the markings, but that's up to your teacher. All right, next. JM is congruent to LN. You know that that's given. You can write that one out. Now this one's a little weird. JM is now congruent to LM. Okay, so if LN is the same as LM right here, they can be interchanged or substituted in for each other. So I rewrote that, put LM in by substitution. Right. Now, number 5, I should say JML, JKL. JKLM is a parallelogram because it's given. Okay, this is where it gets a little weird. Now, if you combine 4 and 5, okay, so 5 is parallelogram, and then what you have here in 4 is a parallelogram with adjacent sides congruent. Okay, that upgrades it to a rhombus. So you can go right there. The next statement is JKLM is a rhombus. And that's because it is I'll write this one out. It is a parallelogram with adjacent sides congruent. Okay, so that's a synthetic proof on rhombus. All right, I did the work for this rhombus. Just would have taken too long for me to go through all the steps. So I completed it, and I'll explain what I did. So I graphed figure ABCD. Okay, so that's what it should look like. And they wanted me to prove it was a rhombus. Now, strategically, I choose the fastest way to prove it because they didn't tell me it was a parallelogram. So I have to come up with a lot to prove it's a rhombus. Okay. If it was already a parallelogram, I'd have probably just done two sides. I would have calculated the length of AB and BC, and that would have been enough. Because I didn't have that it was a parallelogram, I had to calculate the length of every side. Right? Somebody asked me, well, why didn't you calculate the slopes? Slopes would be great for rectangle or parallelogram, but because for rectangle you could show the angles are 90s. For parallelogram, you could show this both pairs of opposite sides are parallel to the slope. With rhombus, the slopes are not enough, so I didn't bother with that because I'd still have to do more work. I do know though, if I can get all four sides the same, then I do know it's a rhombus. So that's the least amount of work that I can calculate and still get a rhombus. So I calculated the length of each side. Students argued with me last year about this. Well, why do you have to do the same Pythagorean theorem 4 times? You just have to play the game a little bit sometimes. So they're going to require and score points for seeing 4 calculations. They're going to award a point for that, or 2. So show them all. It's not that hard. Once you complete the Pythagorean theorem for one of the sides, if the other sides happen to use the same numbers, just do them again. Now, I did the distance formula on CD just to show you the distance formula one time. It's really the Pythagorean theorem. You're probably thinking, well, what's -1 squared? Where'd that come from? -1 squared in parentheses, the -1 in parentheses, and 1 squared are the same. You square a negative, it's still positive. 4 minus 0 is 4, so 4 squared is 16, just like it happens up there. So CD ends up being square root of 17 as well. Now, in our proofs, after your calculations, you have to give a statement as to what your calculations tell us. Now, the calculations are on length. When lengths are equal, the sides are congruent. So I've got, in this case, I've got all 4 sides are congruent, so I put them all in one statement. And I tell why, because their lengths are equal. Perfect. That's what we would call the conclusion. Now, take the conclusion and say, well, what does that give us? It gives us a rhombus now because it has 4 congruent sides. And that's how you would complete this type of proof.